Hello, everyone. Um, Turn the fan off for now. Hello. Uh, I'm going to do a solder session tonight because I have this PCB that I've done that I want to see if it works. You know the drill. It has happened so many times before that it doesn't work, but so I've done this PCB before, and it didn't work, still doesn't work, and I did the rookie mistake of in a schematics where, so I copied another schematics, and one of the places where it just one line goes over another line, it was connected, so that messed this whole thing up. And I've tried to fix that with some budgets and stuff, but I decided to start from the beginning, and also just while I was remaking the layout, make the layout a bit bigger, because this is a, I'm just gonna see, so I have some sound. Yeah, I have sound. I want to expand this to have quite a lot of other features and to become a somewhat cheap VCO alternative with CV tracking and all that. So I have remade this, and again hoping that it will work. This is, in this current form, it is the same schematics and design that I did in, I think, week 1, episode 2 or something like that, the AAC VCO. So this one did work. I also remade that when I made the proto boards, so it looked a bit better. Here I added the high and low frequency rates, so it was both a VC LFO and a VCO, which was nice. And then I took this design onto this, and it didn't work anymore, but that's because I made mistakes, of course. As happens more often than not, sometimes, I think. So, taking this aside, here's the schematics, and here's the bill of materials. So I'm just gonna work with this and solder this together. I have a bunch of components. Maybe I don't have the right aesthetics here. You're supposed to have a few components up in the corner, right? And that one shouldn't be in picture. Should have some capacitors here. Have some green ones. Here. So now it's a soldering video. Shout out to Moritz Klein. I'm just messing about. Love your videos. Very interesting to watch and learn. Yeah. So without much further ado, let's start soldering. Only bad thing with these when doing this live is that I don't have any audio, like music audio. Oh, sorry. When I sit and solder by myself, I usually listen to music, but can't do that when YouTube is listening, because then I get a copyright strike. So if anyone wanna go online on Discord or something, and maybe you wanna do some jam in the background, let me know and I'll connect and someone can play some music in the background of your own non-copyrighted music if you want. We wait with these, of course. Let's start with the resistors. I always start with the... Oh, wait, there's another one. I like to start with these IC holders. And then after that, I usually go with the resistors. Yeah, troubleshooting skills are the most important. I agree. I did a lot of troubleshooting on the other one and did find a lot of them, but I still didn't get it to work. So I'm guessing I had bodged it up too much for too long. So something else maybe broke. Right, so I see sockets in place. 10K, what do we have here? We have we begin with 10K resistors, R1 and R8. That's all we need there. And R1 and R8, it's not 10K, it's potentiometers. R1 and R8 are both potentiometers, so we don't need that. Let's skip those then. They're trim pots, not trim pots. So let's take 100K. That's a whole bunch we need here. 1, 2, 3, 4, 5, 6, 7. 2, 3, 4, 5, 6, 7, 8. 4. Hello, Al Tofanelli. Hope you're doing good. R1, R3, R4. These are just the CV inputs up here. And then we have R9. There we have one. That's the... So I've made some notes here. So here's the voltage exponential voltage input. So here's the beginning of the oscillator. This was R9, R13, R14, and R16. Let's continue adding some 1 meg. We have that here. One meg is R5, that one, and R18. So this is the fine tuning knob. So just a knob like all the others, but with a 1 meg resistor in series, you get a much smaller difference in value. Therefore, it becomes a fine tuning. 1K. Oh, I do have one 1K resistor. R6. There. And 22K. R7. It's quite easily laid out right now, so hoping to keep that flow in the future as well of this one. And then we have 56K resistors, and I do have 56K resistors, but let's look at this. So in the schematics, the exponential voltage comes in here. So this is the oscillating circuit, or this here. These are just buffers, but this here is the oscillating circuit. So we have 100K there, and then we should have half of that on the other one. So actually it should be 50K, and the same goes down. So half of that, 50K down from the R9 input 2, and 50K there. And I put 56K, but actually 47K is closer to 50K than 56. Most simple of math. So I'm going to use 46K instead. And also, I have way more of 46K than 47K than 56K. So that's also a reason. So we take all these 56K, we do 47 instead. Let's make a note of that so we know if something should fail, I have something to blame, except myself. R10, that was R10, right? Yes, that was R10, R11. R11, R12. Up there. And R15 down there. That should be all resistors. Remove that, and the 22K we are done with. Great. Let's solder these in place before I drop this or something and have to start all over. This one's come loose. It's quite a new soldering iron for me. It's really nice, but I'm not quite used to it yet. I'm used to my old one. And this is a new digitally controlled with everything just a cheap one from Ali or Banggood. I don't remember where I bought it. I actually bought it because I needed the this one, the hot air gun, which I've tried a few times, burnt myself a few times already. That is super hot, and you don't think, or I didn't think that the whatever I was aiming it at got super hot as well, so did a few mistakes there. It's the best way to learn is to experience it. And pain is such an experience. Harmo, it's the full VCO. So it's the full AAC VCO, but I want to add a bunch of other stuff. So I want to add pulse width modulation. I want to add a sinus wave shaper, and maybe even a wave folder, because that was easy enough to add. So that's why there's a lot of empty space here. I'm thinking sandwiched version of a VCO. This would be quite a good size, I think. Bad Chisel, I admire your dedication. Yeah, I'm like you. I also have a tendency to lose my momentum and move on to something else. Sounds very much like me. That's one of the reasons I'm doing this as a series and on YouTube, for everyone to. I did get like really tired of it, like a year ago or something, and then I remember everyone was, when's the next video coming out? What's happening? Are you okay? Everything like that, and that was good because that got me back on track. So having other people expecting things of you is a good whip to stay on target, I think. So yeah, I can recommend that for that. For that reason, I guess. But yeah, another reason I keep doing this is my modular is still not finished. I need better VCOs. That's why I'm doing this. I'm not satisfied with my VCOs. I actually cheat a bit by using that one module I did have before I started this project, my SAS VCO, which is a really nice VCO, but it's the only one I got, and I haven't. It was pre-built, so to say, and I want more VCOs, basically. So, and then I want more of everything else, and I want newer, better things. So I'm slowly working up towards that. If you saw the video yesterday, just the short video where I caught some magic smoke on camera, I'm working on this. You've all seen this one. I've had this a long time. The Touch Me Now, just touch panels, super simple. But I've made a companion PCB for it, because I think many people who bought this or made this or whatever just got stuck with this board and haven't done anything on the backside. So I just think that it would be nice to have the board as well. And I was so certain this worked because I've tried this so many times, but apparently I've been frying this capacitor here on all my other boards. So I went back, so here's a prototype, and I believe that capacitor was blown there as well. So that's the mistake on these boards. Other than that, these are done, and I'll have a video on that too someday. I'm working on that too. Where's my... It's magic. We have to believe in something. It's magic smoke to tell us that we did something wrong. Imagine if every time you did something wrong, there was some magic smoke that told you you're wrong. That would be magic, wouldn't it? So that's why it's magic smoke. You can learn something here. There. It's not that difficult to build this, actually. There's not that many components. And we're using LM324, so we only have, it's a single rail op amps, so we only need one of those 100 nanofarad capacitors of each. Those are tricky. They're so small, the footprints on these. So then we have some transistors. I'm guessing, I'm not fully certain of it, but I think that these two that are connected like so should be thermally bonded. They are not today, and I will not bother with that today either. But it might be. I found a few chips that do I have some of them here? I have them here. I haven't tried these, but I have found DMMT3904. So these are surface mount chips. Let me take one out here. And again, I am not fully sure. I haven't read the data sheet or anything, but so this is a 6-pin chip. I don't know if you can even see that. But this is 2 matched transistors in here. So my thought was that I could use one of these, and if I need a Temco or temperature coefficient resistor on that, I can just lay it on top of that one, that little thing. So it's a thought I had. I don't know if it's gonna work. You have smoke coming from your ears. That's you should look that up. Yeah, right. These. Let's solder them in place. so small legs, or not legs, the pads for these are really small. And I know I can choose this myself. In the design, I could just go in and choose to make these pads bigger. But I'm always in such a rush. Don't know why. It's just the way I am. I'm just gonna look at this. They're also very close to each other, so yeah, they're fine. They're fine. All right, C2. We have to check that. That's the oscillating. Let's see what we used on the other ones. Right, so here we had either 4.7 nanofarad, or so it's probably 4.7 nanofarads. The other one is for the LFO part. 4 and 7, we have that here too. Let's go with that. We could add a header here, actually. It's not half bad. That way we can try other ones. So this way we can just add that and we can make sure that it works. I'm probably going, no, I'm not going to say that, but knowing myself, I might forget this and try this and think that it's all broken. I forgot the R17. So let's just try to remember that I'm not going to do that. I missed the resistor out here. these caps, are they correct this time? Plus to negative, minus to ground, plus to I turn these the wrong way all the time. I actually turned it the wrong way here too, I can see that. Let's see, let's just skip these for now. I'm skipping the ripple capacitors. Yes, it's not important right now. Now, what's important is we did that, and we need the trem pots. 10K. I only had these tiny ones with really tiny screws. Buy. Need to buy that. They fit, but I still prefer the one with the knob on them. I usually buy these because it's really simple to dial in what you want. Okay. And the power strip. And we are done. This one should go in there. That was hot. Need those two. I don't have that many LM324s though, and these are worth their weight in gold nowadays for some strange reason. So that might put a sour ending to my search for more oscillators. And for this to work, now we need to have an input on the CV. We need a CV input, or else this won't work. Oh wait, let's take some ready made ones here. So we have one there. Just gonna solder that in place. And then we want the outputs. We can wait with the outputs, that's not important right now. We need ground though, and I think I have that here. Ground, that one. That one? That's ground. Oh, the tool I used, this one. This is, I bought it a long time ago, from Breadboard Maniac. This is quite a good tool because when you buy ICs, they're all, the legs are always bent out, which means, let me show you with a new chip and a new of these. Nope. For whatever reason, that when you buy a new IC, the legs are just a wee bit out like this. So when you try to put them in, they're just outside, and then you either need to sit and press them gently with your fingers, or you need to like press them in and squeeze them in. What this one does is you you put them here and then you just push it in, and that aligns the legs, so then they're now straight and you can just push them in. So it's a really simple but nice tool, and looking at it, this should really be super simple to 3D print. Just like 3D print those canals and just make them a bit wider at the beginning and in like that, and it should work. So I like it. Some people might think it's a waste of space maybe, but for my use I really like it. Right, so good. Let's do some, let's check some connections just for the show of it, so it looks like I know that there's no shorts. Let's begin here. Looks good. Yep. And we got voltage plus. Let's see, that should be pin 4. 1, 2, 3, 4. It is not. Pin 4 here. We check the schematics. Pin 4 is connected to VCC. And we all right, we have a diode in the way as well. Right, so we need to make sure to check in the correct way. There. Like there is a connection, and then from there to there and there to there. Yes. I have added a 1N41 4001 or similar, just to have that small protection. So if I turn this the wrong way, I won't fry it completely. Hopefully not at all. But yeah. So with that said, we need to connect some test equipment here. We can keep this one here and there. And I looked, I didn't mess up the capacitors. Actually, we can plug these in because they're correct. I was just looking at the schematics the wrong way. Plus is the long leg. Plus is the long leg. So let's add those two as well. And we'll have that done as well. So no one can blame us for not having those. And being the last solder of the evening, of course, I botched it up. There. Let's check again, so I don't have a short here. Nope. It's fine. Let's just hope that we don't need the solder section anymore, and instead we need the oscilloscope. Here we have that, and we need, let's see, get close, and we need power like so. Sorry, just gonna do some logistics here, moving things around. We don't need that one. Again, everything. C1. No, I'm still missing one. C1. 1 nanofarad. What was that for? Why did I miss that? One nanofarad down here. part of the voltage input. 1 nanofarad. 1 nano. C1. I don't have a proper solder suction. I just have a fan like this, but it does. Sorry about that. I don't know, what did I get into now? All right. I think it works again. I need this because my power supply here I have a small output here. I can control how much output I get on that one. So we can try. Right, let's start by maybe it's even better with one of these. Let's see if we get any magic smoke or what happens here. And so nothing too warm there. Let's just hope that that means it works. We don't have anything, not on the triangle, and let's see, triangle and square, and not on the square either, I'm guessing. No. But what happens if we add some voltage here? All right, we have nothing. And where's this oscillator vexes me, I think. So I think that is yes, ground number 2 is that one. So we can try that and just check. Let's get 1 volt input here. like that. And that's pin 7 on this one. So there we have 0.029. Not sure how much we should have there, but we have a trim pot. Let's see what happens if we turn the trim pot a bit. Not very much. It's a multi-turn, so that does nothing. Right. What do we have? Let's look at the V-Expo out. That's U22 and that's U2. So, no, there. Pin 14 out. 14, it's 0. If we turn this up, nothing happens at all. So does not smell funny, if you wonder. Just making sure. Do a sniff test from time to time. Let's just continue turning these then, I guess. I don't know, there's how many turns there are on this. Not the best of screwdriver either. I must be somewhere. I'm looking at the schematics, trying to figure out where I went wrong. I'm gonna take up the old and the new one on my screen. I'm streaming from my phone, so I can't really show the screen today. Sorry about that. That one is correct. VN. And then we go to VN here, which goes into a BC548, which I'm using, which goes down to there and to that one, which goes to ground, and 1 nanofarad. Yes. And then it goes back into there with the 1 meg resistor to voltage plus there, which is correct. And then we go to the other BC548, which is also connected like that. That one is connected to ground, correct, and that one goes into an op amp on the inverting input. The non-inverting goes to ground, and then it goes up to a 22K, to a 10K trim pot, and then we should have V expo out. You know what? Let's do this. Let's bring this into the picture as well. Because then we can compare the two. I need to get some more stuff. Right, let's see. So we have this one. We want the CV to be the same to both of them. So we'll solve that like so. And then we will add one there, and we will add one there. And then we need power to this one. DuPont cables. Let's see. Yes. So this one is from the early days where I didn't use the Eurorack format of power, but I used these 3-pack of DuPont cables, where blue was plus, let's see, blue is plus 1, 2, 3, 4, 5. Purple is ground, and gray is minus 12 volts. There. If we take a look or take a listen to this one, that one works perfectly as it should. Well, maybe not perfectly, but so anyway, we're just gonna check some things. CV input, we have that in there. We are guessing that this one goes out on that one. .86, and on this one it was nothing, 0.002. I don't get this. Same input, completely different. I mean, this is the first circuit. Bugs me. There's one way we can just make sure that everything is the same in the beginning. We remove the op amp. This way we can check the inputs, so the inputs are totally the same. Without having the op amps, the whatever. What's wrong with that? Why don't you like that? All right, so for some reason it doesn't like to do that. That should not matter. That works. Let's try this one then. actually don't need the negative voltage, if that was the problem. Okay, I'm getting caught up in the old VCOs, that the old VCOs are acting up now. Right, so disconnecting the minus voltage solved the problem for now. So on this one we can, oh no it didn't, because I put the, I put the IC back in. Okay, so this one's hot. Why is that one hot? Did I accidentally short something here? Or did I accidentally turn this the wrong way around? Memories. I have to check this. Yeah. Okay. The really pro with this one is that you can, of course, you can turn it the wrong way around, but usually you don't. I forgot how I connected these, so I switched them around. Let's hope I didn't destroy too many chips. This one was really warm. Fine. So everything works now again. .94. So that's correct. And on this one, that should be inverting, right? Okay. Pin 7. 3.22. So it's just a buffer. If when I put that back in, that will just be a buffer. And on the output there, it shows nothing. Oh, you go in there. All right, and then you go over there and there. So that should be 4.45. Okay, so we know 4.45 works. Let's tune this so we get 4.45 then. And again, nothing happens when I turn this, which is so weird. Have I already broken that one or something? 20 key. Let's between that one and pin 6. So it's at 9.7, so it's almost at maximum. And this one is at 2K. But I don't seem to be able to turn this one. So the question if this one has fallen out of the track or something, because no matter how much I turn this, it stays the same. We could solve this by adding a 2K resistor over the pins. This is just to try it out. I'm just going to solder a 2K2 resistor in place here, just to see if that does anything. Might be a good idea to turn the power off when doing that. Come on. Right. So now 1.75 and 2. So we're closer. There's still no, we don't know that. Let's find that one. Let's see if we got any oscillation here. Yeah, we don't have any oscillation because we're missing like half the op amps, of course. Let's continue. Second op amp we should be checking is here, the V Expo out. Harmo, yeah, you spent a lot of time with this one as well. I don't know why. Why is this one cursed? I mean, I built two. The first one, it looks like this, and it still works. And the second one here also still works, well, except for maybe that I fried the op amps now, but other than that, it's so weird. And then after that, I haven't gotten a single one to work. Anyway, V Expo out. So that's 1, 2, 3. Should be down here somewhere. We have the second one. One, two. No, it's that one. There's the second one, so output should be... We can't do that without the op amps. We need the op amps now. LM324, yes, it's the correct kind. Just wanted to see, so this one works, and it seems to work, but very... Here we have it. All right. Except that I can't tune it. It seems to work. Yeah. But not this one. Not that one. Right. So we were saying output on, still use ground from over there, and we want voltage again. So output from this one is pin 1, right? 10 volts. Again, this one might be fried now. 14 was this one. This one is still 0, even though with the new resistor, it's still 0. Three. Minus 3. I just have to check on my kits. Just a moment. Pin 14 continuity checked. True. That's a good check. Let's check that. Pin 14. It should actually, we could check pin 14 and pin 13 should have some resistance. They do. 32K. So again, this 10K resistor is at max. Don't understand why it's at max, and that should be those two pins then on this one. 41. No. It's funny, it's negative resistance. How can it be negative resistance? 41. So, and that goes from Q2, so that works. I've checked the schematics with the in ECDA, so just check so there's no loose connections, which there isn't. So that is correct. But again on the output here. That's not the output. Yes, it is. That's the output. I get too much, like so. Okay, so I probably screwed this chip. Let's replace that chip. Let's just error checking an error that could just be that I fried the chip. LN358. Doing that again. Still can't tune it. Does it still have the same value then on the output? Yes, it still has 10.81. So it's not the chip then. All right, 10.81, 11 volts output on this chip, and on this chip it is 0. And I did not forget to solder it in place. That's good to know. And you know, when you go down on error checking the traces on the PCB, that's so pin 14 is supposed to go to no, R9, R10, and R8. That R8 goes down there to that one, to V Expo N, which is correct, yes. And then we have some solder mask in the way. I'm just gonna see if that is, these two are connected. They are. And that one is connected to pin 14. So that is correct. So continuity, check that is pin 14. Yes. Yes. It works. And those two are connected there. Those two, yes. So that's correct. Two circuits. As far as I can tell, they're exactly the same. But one shows 0 and one shows 11 volts. Let's measure some other points. Let's see. R6. I need to look at this one where R6 is. R6 is the second one. R13. R6 shows 0 volts as well. So that's the emitter of the first transistor. Sure about Q2? How do you mean sure about Q2? We can check. Q2 is that one. The base should be to ground. It is. And then we had pin R6 was the second one. Yeah, the emitter is connected to that one. And so then that one should be connected to pin 13 on that one. Yeah. CBE, right? Yes. Yes, Q2 is correct as well. R5. Let's see. R5. That's the first one. That's a 1 mega ohm resistor connected to voltage plus. Voltage plus is that one. CBE. Yes, correct. And also connected there to the not inverting input. Yeah, thanks. I need a rubber duck. Since I heard that phrase, I think it's you who told me that phrase. That I have a friend at work who gave me a rubber duck and just calls me and say, "Ah, I need a rubber duck," and then he calls me. Maybe I should just have some smiley people here somewhere. Nope. They have escaped. Anyway, maybe I should use them as my rubber duck and just sit here all night and try to figure this out. I'm looking at this old schematics as well right now, so that's why you can't, nothing is happening on screen. You know, there is the possibility to cheat as well. I have this one. Let's cheat. Let's do this. Let's remove this one. We don't want that right now. Let's simplify this by removing this one. Let's take the exponential converter out of the equation by doing that. I connect that there. And with this cable, so let's remove that one as well. This whole thing, let's remove that. Ah, look, my table. So this is ground, we don't need to worry about that. But this one is now, let's see, let's get this 1 volt there. If we add this to the V-expo input, we add voltage straight into the oscillator, which should start oscillating. Doesn't. Did you get yours to work, Harmo? No, nothing there either. This is so fascinating. Like, I've tried this so many times, and as you say, Harmo, that you didn't get yours to work either. Maybe I should give up this design then. Try some other. Luther's or Moritz Klein has made some really nice basic VCOs. Could even be very similar to these ones. I haven't looked too much at them. It doesn't even react when you add voltage to the V-Expo. That is an integrator. So when adding voltage in on the exponent V-Expo, this integrator here should react depending on how much voltage it is and rise through the 1U slowly, or ramping up to that's if we take this one and we listen to U1 pin 1, that's U1 down there, yes. If we listen to that pin, and we look here, and we add voltage, look at that. Look what happened there. If we connect it on the other side. Well, we have oscillation. We have oscillation. Do we have it on the output as well? Yes, look, we have both triangle and square. And we can tune it. No, we can't tune it. Not so it looks as if we tune it. All right, so interesting. I'm actually adding, yeah, that should be pin 2, so there. I'm adding voltage input on pin 2 of the, so right after this 100K. What happens if we add it to that one? Nothing. We need to add it to that one. Why? Why? Am I wrong in thinking that it should be 47K? Should we have? Could be. Let's look at the old schematics again. It says 56K in the original schematics. I still say it can't be that simple. Those few ohms really can't make this much of a difference, can it? I'm putting voltage there. It's not very nice. It is constantly moving, but at least we have oscillation. But yeah, not very nice. Let's look at the triangle wave. Also acts very strange with some shelves that just stays up. I'm thinking, why is this like so? And it has nothing to do with buffers, of course. It's in the core. If we listen to, yeah, like in this core right here, that's where the problem that creates this is. All right. I just removed C2 and it continues to oscillate. This is the capacitor that's supposed to set the frequency. Okay, so Harmo and I really believe in your voodoo thing, because the first op amp here, the like where the voltage comes in, this is the integrator. This is the thing that creates the triangle wave where we add, the voltage ramps up and then it ramps down when we go push this one to ground. But the capacitor of the integrator is in my hand. I have no idea. Either that or I've completely misunderstood this circuit. It could, of course, be that as well. Okay, we've come so far. We have oscillation, not the oscillation that I want. But right now, this one is so weird, so I have no idea how to continue error check this. I mean, I can take out the capacitor of the integrator and it still oscillates. That's like super weird. So I need to take a beer, watch Loki, and sleep on this, I think. So let's go and do that instead. It was interesting, to say the least, to do this. I hope to have some projects that actually work. This one works, except for that capacitor that went up in smoke. So this one is coming. I also hope to have this one, a noise module, which I've been working a long time on. I got a feature creep coming in here with a LED behind one of the letters here. So I had to make a new PCB for that. So the feature creep had its own little space on the PCB. But anyway, thanks for hanging out, giving me some pointers, being my rubber ducks and stuff. So hope to see you next week. Next week I've been sick. That's why I haven't been able to do a real video. Not last week. I think I don't made a video, and not this week either. But next week I hope to have the bit crusher schematics done. I'll just go through that then, so it'll have its own little video where we look at the bit crusher one more time before we move on. Yes, Sherlock Holmes. Sorry for that. I am going. I'm working on it. As I said, I've been sick, so always good to have that to blame on. But I have it, and I'll release it next week, hopefully. So check in then. Until then, take care, everyone. Bye. And we should turn the live stream off.